welcome back to a new video. In this video, we are going to discuss the half yearly or the midterm sample paper for the grade 11 CBSE. And the chapters that are covered in this sample paper are the first 5 chapters of the book till the complex numbers. Okay, so let's start with the first question. The first question says that we are given a set B in set builder form and we have to write it in the roster form. Okay, and what we have to write, the condition that is given to us is this: x square equals to x. See, how can we find what are the elements in this set builder? So we will write here x square transposing x to the left side equals to 0. Now taking x common, x and x minus 1, which will be equal to 0. Okay, so now we have two factors, that is either x will be equal to 0 or x minus 1 will be equal to 0. Okay, see, one value that we have got is x equal to 0, and from here we will get the value x equals to 1. So these two elements will be in the set B. So we will write here set B equals to curly braces 0 comma 1. So this is the answer and this is the option D. Moving towards the next question, the second question, we are asked the number of non-empty subsets of the set A. Set A, number of elements in set A are 4, that is 1 2 3 and 4. So there are 4 elements and we have to find the non-empty subsets. So the formula for non-empty subsets is 2 raised power n minus 1. Basically it's the formula for uh, finding the number of elements in the power set of the given set. But in the power set we know as an empty set is also there, so we have to subtract minus 1, that is the empty set is subtracted and we are left over with the non-empty subsets. That will be 2 raised power 4 minus 1, which will be equal to 16 minus 1, that is 15. So A part will be the answer to the second question. Now the third question. The third question says if A equals to x and x is such that the x is a positive multiple of 3 less than 100 and B is a set in which x such that x is a prime number less than 20, then number of elements in A plus number of elements in B. Alright, so in the first set, there are the positive multiples of 3 less than 100. Positive multiples of 3 less than 100. See, multiples of 3 start from 3 itself, then 6, and it goes up to 99. Because 99 is the only multiple, or we can say the last multiple that is less than 100 of 99 is the only multiple of 3 which is less than 100. Now we have to find the number of elements. So simply 99, arithmetic progression we are using here, equals to 3 plus n minus 1 multiplied by 3, n minus 1 multiplied by 3. So it will be 96 divided by 3 equals to n minus 1, which will be equal to this will be equal to 32 equals to n minus 1, that is n of A. Number of elements in set A are 33. Now we have to find the number of elements in set B. Number of elements in set B are x is a prime number less than 20. So how many prime numbers are less than 20? See, 2 is a prime number, then 3, then 5, then 7, then 11, 11, after that 13, after it 17, and the last one is 19. I hope I have covered all the prime numbers here. So these are 1 2 3 4 5 6 7 8. N of B is 8. Number of elements in set B is 8. and we are asked the sum, that is n of a plus n of b. So n of a plus n of b will be equals to 33 plus 8. 33 plus 8 is 41. D part is the answer. Now moving towards the next question, that is the question number 4. That, let me just remove all of this. Okay, now we have to see for the question number 4. So the question number 4 says that we have to find the domain of this function. Question number 4. Question number 4 says we have to find the domain of the function, which is fx equals to 1 upon square root of x plus modulus of x. Now for this function, for finding the domain of this function, we have to find all the values of x, set of all the values of x, which make this function defined, which define this function, for which this function is valid. Okay, so we will write here. Now, as we know, first of all, the first condition will be x plus modulus of x will never be less than 0, because this thing cannot be equal to 0. The thing which is inside the square root cannot be equal to 0, and the denominator itself cannot. Uh, the thing inside the square root should always be can be equal to 0 or maybe greater than 0, but it may not be less than 0. And mm, okay, so the condition here which we will write is x plus modulus of x must be greater than 0 for this function to be defined, because there is square root and the thing inside a square root will be equal to or greater than 0 always. But uh, since the square root is in denominator, that is why the equal to sign gets removed from here. So we get x is great. Since there is modulus of x, so the modulus opens in two parts. That is, the first part will be x plus x will be greater than 0, and the second part will be x minus x will be greater than 0. Okay, we have just opened the modulus, and the modulus opens in two ways, that is plus and minus. So it will be 2x greater than 0, and here it will be 0 less than 0, which will which is not a good condition. So we will write here x is greater than 0. So this is the domain. We got x is greater than 0. So D option will be the right answer for this question. Now moving towards the next question, that is the fifth question. The graph of the identity function. We are asked for the graph of the identity function. I hope you all know. First part will be the correct answer. Now comes the sixth question, which is from complex numbers. We are given two complex numbers z1 and z2, and we have to find the sum of z1 and additive inverse of z2 is equal to. Okay, first one is z1. We have to find the sum of z1 and additive inverse of z2. Additive inverse of z2. We have to find the additive inverse of z2. Now, how to find the additive inverse of z2? This is the whole thing in this question. That is the word additive inverse. We are not asked for the multiplicative inverse. We are just asked for the additive inverse. So additive inverse of z2 will be z2 conjugate of z2 simply. that will be 2 minus 3 iota. Now we will write here z1, and z1 equals to 1 plus 2 iota. Simply adding both of these, 2 plus 1, that is 3, and here will be minus iota, but that is not in the option. So yeah, the additive inverse, let's just take it as minus 2. It will be minus 3 and minus iota. Minus 3 not, it will be minus 1. Minus 1 and minus iota, which is in the D option. So our D option will be correct. Minus 1 minus iota. D option is the correct. Okay. Now next question uh, is a very famous question, and you must know for which set of values this inequation, or we can say the inequality, is valid.